Welcome to section 4.4. Now, we are coming to the end of our semester, and this particular section is going to deal with some old rules, but negative exponents. We have some old rules that I am going to refresh your brain with, but what you're going to see in the problems now is a lot of letters, and some exponents are going to be positive, some are going to be negative. When you work with this section, the important point to know is you must make all exponents positive first. This will make your life a lot easier. So let us review some rules that came in prior cycles. Well, as you remember, we had what we called the product rule, where we added exponents. Then we had what we called the quotient rule. Now notice, the quotient rule had, in this particular case, the same exponential base, which was x, but the exponents were different. Unlike Rule 6, this is the product rule of fractions. It's different than 2. Okay. So number 1 was your product rule. Okay. Number 2, this was your quotient rule. Okay. This was the power of 0 rule. Okay. Now, this one was known as your power rule, or what I called the piggyback rule, because you had exponents back to back. And again, this was also your power or piggyback rule, okay, for number 5. But with number 5, you had to realize that inside the parentheses, the x had an exponent of 1, the y had an exponent of 1, and we then distributed a multiplied by 1, a multiplied by 1, which is how I got x to the a power, y to the a power. Now, number 6 is an old rule. This is the product rule of fractions. This fraction has a different numerator and has a different numerator and denominator. But you are distributing, just like 5. We have a power of 1 for that x. We have a power of 1 for y. It distributed, which is how I got x to the a, y to the a. And again, if x to the a and y to the a could be reduced, I now would still reduce them. All of these are old rules. If you need your notes, pull them out. This is just a review sheet. Now, this is where we're coming with the negative exponents. Now, as you know, every fraction has a reciprocal. Well, the negative exponent base is going to flip. Now notice how this works. We have x to the negative a. We are going to know that there's a 1 underneath x to the negative a. It flips. This is my reciprocal. And an example would be 2 to the negative 3. I would then rewrite this by putting a 1 under here and then flipping it 1 over 2 to the positive 3. This is my reciprocal. Now, the next problem is basically a shortcut. This is saying that I have a fraction. Okay? This is 1 over x to the negative a. Now, I'm going to take a whiteboard and watch what I do to get the answer. Okay? What I'm going to do is I have the fraction 1 over x to the negative a. Okay, now watch what I'm going to do. This is where the negative exponent is. This means that I am putting a 1 to create this denominator, which gives me what I call a complexed fraction. What does this fraction mean? It means 1 divided by x over negative a to the 1. This means this step. But remember, we have a fraction and we are dividing. That's what that line in the middle between 1 and x to the negative a power means. And that means this fraction is going to flip. This is 1 over 1. Now this becomes 1 over x to the a power. And we're multiplying. Okay. 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 This means